So let's apply our knowledge to a particle system. Control and click the shop tool. And we didn't create a location particle system for us. And we just need one frame here. So like so. And then increase the initial velocity a bit. And add a pop drag. Tune down it a bit. And remove gravity and take a look. It looks good to me. So let's copy the rubber tool and some nodes here and paste them here. And let's pass this temporary and turn on packet instance and take a look. It's too big, so let's randomize and make the P scale smaller. It's a one dimension. Size is between 0.1 and let's say 0.2, like so. Okay, as you can see, the initial orientation is aligning to the velocity direction, like so. So let's edit this part a bit. This time we want to use only ROT. And let's make this a variable and the axis a variable too. Let's call it axis. Okay, so the degree is a float. And let's promote it. Also call it DEG for degrees. And the vector is axis. Let's make it a normalized velocity vector, like so. Promote it. And let's enable a wrangle and try that. As you can see here, it's rotating around the velocity direction, and we can actually use $ff, maybe multiplied by 4, maybe faster, and like so. And we can also multiply it by the speed, so it's length of v. Take a look. So when it moves slower, the rotation will be slower too. So now let's try the same setup but using the orient and see what will happen. So let's connect it. And as you can see here, the rotation is not right. So why is it that? That's because now the orient attribute has higher priority than velocity. So now the instance no longer aligns with the direction of the velocity. And it falls back to the default direction, which is positive z. So we need to make a compensation for that. So we need to create a quaternion. Let's call it correct. COR stands for corrected quaternion. And there's a function called dihedral. And the arguments are two vectors. One is the default positive z direction, and the other is the axis. So this function will return a quaternion that will rotate from this direction to this one. So we can apply this corrected quaternion to our orient. But we cannot multiply them directly like a matrix. We need to use another vex function called, just one moment, let me type this down first, called qmultiply. So the first argument is orient, and the second one, of course, is the corrected quaternion. So now the rotation is correct. To conclude, if you only use Houdini, ROT is a better choice because you don't have to worry about orientation. ROT just adds extra rotation based on the original alignment. On the other hand, if you have to export your particles to other 3D packages, then Orient is a better choice because you can convert it to other rotation systems such as Euler, and other 3D package can pick it up quite easily. So it depends on your application. So that's all for this tutorial, and I hope it helps. See you next time. Bye.